All right, so the final transition has to do with asynchronous code. When I first started out building PHP Monitor, there was no such thing as async await in Swift yet. It was a fairly recent addition, in fact. Now, recently I've been adding async functionality to PHP Monitor. This is why, actually, a little cool tidbit, if you go and look in the phpmonitor.app file in Finder and you inspect the package, you'll see that there's a library included, which is what Apple generates. Because it is a more recent addition, it is not built in, baked into legacy versions of macOS and legacy versions of iOS, so it has to ship as a kind of an extra binary as part of your application. So this is why the app got a little bit bigger. It's a small extra blob that handles this asynchronous code. It's pretty cool. All right, so let's talk about the difference. So what's going on? What's up with this async stuff, right? So if we look at the text dispatch queue, you are going to see that there's some dispatching that happens. Let's talk about that. So let me just boot up the app. And in fact, no, I don't even need to boot it up for this. Let's just go to the main menu plus async class. So this is an extension where I have effectively taken this asynchronous approach and I've put it in kind of this very easy to use system. This was a great solution prior to having async await. And even to this date, I think this is kind of a neat solution to solve a problem. So one of the things that happens with PHP Monitor is you sometimes perform an action. And if it is very quick to do, we can do it on the main thread. Like if it's really fast, we can do it on the main thread. But if we cannot do an operation instantaneously, we need to delegate the work effectively to a separate thread. And we do this by using DispatchQueue.main.async, where we are effectively saying the quality of service, that's QoS here. And we can say, okay, what's going to be the priority of this task that we are performing, right? When a user, for example, a good example is the difference between checking for a newer version, right? So when the app boots up, if you manually check for an update, we use DispatchQueue global user initiated. However, if you check for a newer version from the background, what happens is I actually launch this functionality in a separate thread with a different quality of service priority, effectively. So this different priority utility is for tasks that the user does not track actively. So it's like a lower than default user-initiated task. Why is this relevant? This gives you, of course, granular control over your asynchronous functionality. So this is good because it means you can specifically delegate functionality to efficiency cores on, let's say, an M1 Mac, right? So if there's stuff that needs to happen in the background, but you don't want to use up the performance cores, you can use, for example, quality of service utility, I believe. I'm not entirely certain that this is as specifically linked, but I'm pretty sure this is accurate, more or less. However, this entire system, if you look at how this works, what happens is we say, okay, we want to run certain bit of code, which is, and we always assume it's user initiated in this async execution function, which is called in a variety of places. I'm gonna need to see where it is used. Async execution. It's very common here in this one. So here's a bunch of things that happen, right? So basically we provide a closure, like for example, restart PHP FPM. That's something that needs to happen in the background because I don't know how long that might take, right? Your computer might be slow, you might be under load. It's not going to happen, boom, instantaneously. So this happens in the background, which means we don't want to freeze the UI, right? So we dispatch the actual work, the actual command that we run to this separate thread, we let it do its job. And once it is done, we can also associate a bunch of behaviors with this asynchronous execution system here. So we can say, okay, we want to set the UI to be busy, we want to reload the PHP installation, etc. I think this is a pretty elegant way of doing this, but the way this works with callbacks is a little bit outdated, right? And this happens all over the app. We use DispatchQueue.global, and then we initialize, for example, this one. Let's stop a third-party service. How do we do this? Oh, well, we do this by doing this, asynchronously, and then we run the code, and then we have a block, an escaping block. It's like a callback function that we call whenever the work is done, and we do this on the main thread. So once the job is done on this other thread, the other thread is like, hey, main thread, please, run this bit of code that is in the completion block. And usually that means that, for example, this one here has the same principle behind it. We run some code asynchronously, and then we have a callback or just a block here that we run once our code has successfully completed these tasks. So in this case, we send a local notification, and I think we dispatch on the main queue here. We might not even need to do this. It depends on the success function. I guess we should check that. Let's see. No, success is already executed on the main thread, so I can even get rid of this stuff, and it should still work. But that is besides the point. This is the old way of doing things. We now have async await, and async is pretty cool. I should probably type await because that's going to get us what we need. So where this is in use is, for example, in the startup functionality of the main menu. So curiously, there's the check environment function here, right? And this one is, it says await, right? So this means that this function is also asynchronous, right? So this stuff happens in the background. And what happens is we run through a bunch of checks, and they're all defined here. And this is what happens when you boot up the app and there's an issue with your configuration. It goes through all of these checks, and it runs these commands asynchronously. And if any of these things go wrong, it presents an alert with this title, subtitle, description, button, and it will tell you whether the app needs to be actually restarted in general or not at all. And if it doesn't need to be restarted, which is the case for most of these, you can just press retry after you've made some modifications and the app will boot up, right? But effectively, there's this asynchronous block of code that is run, but I don't need to actually say, have a bunch of nested blocks here. Thankfully, all we need to do is declare the block, and then when we run it over here, when we check the environment, we can just do if await check.succeeds, and then our check passed. And if it didn't, then it failed, right? We don't need to wait for a completion callback. We don't need to check whether it failed or succeeded inside the callback or any of that stuff. We can just call it. It's great. And so some of these things have been modified. So for example, here's one. This is an async friendly version of the switcher, right? Which can be invoked in certain places. So switch to PHP is one here that we can call. And I think it is used here in the switch to PHP version if valid function. And where do we use that? I just want to check. It happens here. So when we apply presets, yeah, that's a fairly recent addition. So basically that's the thing, right? So we want to move away from this old way of working with asynchronous code and instead move to async await, which is already being used. And like I'm showing you here, I've already written some versions, right, that are compatible with that. So I'm wrapping some of this functionality in asynchronous methods. So this, for example, is what would traditionally be asynchronous code. Like it switches, there's a switcher that performs a switch to a specific version, and there's a completion callback, right? But to make such a thing work with this new async await system, you need to use the with checked continuation result, which tells the asynchronous function that, okay, we're done with the work, right? So you need to call that stuff yourself in your callback functions if you're kind of migrating away to this new system. If you have some legacy code in. So it's gonna be interesting shuffling all of this stuff around. There's a bunch of things about the new async await system that is kind of interesting. You have to declare actors, for example, which is one of those things kind of weird that I didn't really understand very well at the beginning. But basically, you need to say, and this is very useful for UI classes, you can say, hey, this UI class, all of this stuff runs on the main thread. And once you annotate a class as running on the main thread, or not, right? You can say this class is just, regular, like we're going to annotate individual methods as being, main actor functions or not. The main advantage is that you don't have to think about dispatching at all anymore. Because when you invoke code, when you run a particular function, the system knows whether it needs to run on the main thread or not because it's been annotated as such, right? That does mean that, of course, if you try to run asynchronous code in a synchronous context, you're going to get a bunch of warnings. So you need to make the appropriate changes to make that possible. And the way to do this is to use tasks. If you don't use tasks like this, the code is just gonna it's gonna break. Basically, the system doesn't know which part is asynchronous and which isn't. It has difficulties deferring, to different thread or whatever. That way. It's an incredibly intelligent system like SwiftUI. There's a bunch of stuff that is removed. It's less difficult, but it does mean you have to set things up in a way that makes sense. More on this because this is a rather difficult topic and I'm just barely scratching the surface with this whole video that I'm recording right now. It is a topic of interest to me, and I think I need to do a deep dive as well before I can properly explain and just refactor this entire project as well. So it's going to be interesting for sure. That is the last pillar of the major changes that I wish to make. So that's it for the videos for today. And when I make some more progress, when I start moving things around and building new things, I'm going to make more of these videos that hopefully you find interesting. There will also be some videos, of course, on how the app works in general as well. But that's it for this initial video series of why my code sucks. There's some work to be done, and I'm hoping that you will join me for future sessions. If so, give me a sub, and you'll see it when there's some new content, when it pops up in your sub feed. And if you found these videos helpful, please leave a like. Thanks, and see you on the next series.